In this video, we're going to look at the relationship between f and f prime. So we have f of x equals x squared. So when you graph it, you get a parabola. Now, using the definition of derivative, you know that f prime of x is 2x, and that's a graph of 2x. Now notice, when x equals 0, the slope of a tangent line is 0. That's why f prime, which is the slope of f, is 0. You could think of f prime as the y values. So in other words, if f prime is negative whenever the graph is below the x-axis. If f prime is above the x-axis, then f prime is going to be positive. So let's take a look at the slope of f. From negative infinity to 0, when f is decreasing, looking at from left to right, from negative infinity to 0, f is decreasing. That means slope of a tangent line will be negative, because since the f is decreasing. That's why f prime is below the x-axis from negative infinity to 0, because f prime is negative. What about from 0 to infinity? F is increasing. That means the slope of any tangent line from 0 to infinity will be positive. That's why f prime is above the x-axis from 0 to infinity. We'll look at some more examples. On the left, we have y, which is the same thing as f of x. On the right, we have y prime, which is the same thing as f prime. So y prime is the graph of the derivative of y. So just think of this as f of x, and think of this as f prime of x. And let's take a look at the relationship between the two. Now notice at x equals 0 for y, slope at 0 is 4, it's given. Obviously the function is increasing, so slope will be positive. That's why when you look at this graph, y prime, at 0, y prime is at 4, because the slope of y, or f, was 4 at x equals 0. What happens at point B? The slope is 1. So at point B, look at y prime. Y prime is at 1. What about at point C? At point C, slope is 0. So at point C, y prime is going to be 0. What about at point D? Slope is negative 1, because function is decreasing. So at point D, y prime or f prime is negative 1. What about at point E? Again, the function is decreasing, and they're telling us the slope is negative 1. So at point E, y prime is negative 1. And point F, slope is 0. That means y prime will be 0 at x equals 6, which is point F. So from 0 to 2, slope is positive. That's why from 0 to 2, for y prime, the graph of y prime was above the x-axis. What about from 2 to 6? From 2 to 6, function is decreasing. That means the slope is negative. That's why from 2 to 6, y prime was below the x-axis. And from 6 to 7, function is increasing. Therefore, from 6 to 7, y prime is above the x-axis. Now they want us to sketch the graph of function f that has the following properties. F of 0 equals 0. That means when x equals 0, y value of f is 0. So there should be a point at 0, 0. The graph of f prime, the derivative of f, is shown in the figure 3.4, which is on the right side. This is a graph of y prime. And third, f is continuous for all x. That means we could draw the graph of f without lifting our pencil. So what will be the graph of f that satisfies all these three properties? Let's look at the slope of y or f. From negative infinity to 1, the slope will always be negative 1. What about from 1 to infinity? The slope is positive 1. And notice, you don't have any slope. You have no slope at x equals 1. So the graph of f of x would look something like this. So when x equals 0, y value is 0. So we know that it has to go through that point right there. And the slope from negative infinity to 1 is going to be negative 1. So from here, since the slope is negative 1, you go down 1 and right 1. And you connect these 2 points and you get a line. Now what about from 1 to infinity? The slope is 2. That means from here you have to go up 2 and right 1. Up 2 and right 1. So you get a line going up this way. And it says f is continuous for all x. So that means you have to draw the line without lifting your pencil. So this is a graph of f of x that satisfies these three properties. Now, on the next section, we're going to talk about why f prime or y prime does not exist at x equals 1.